The main objective of the least cost method is to minimize the total transportation cost. That is, transport as much as possible through the cells where the unit transportation cost is lowest. Now, what do I mean? Let's take an example problem and then use the example problem to understand the Matrix Maxima Method or the least cost method. So with the table we have here, which is our example, you can see we have the transportation table with the unit cells. So from D1 to D3 and then from O1 to O3, we have our cells from 1 to 4, 4, 3, 2, 0, each field over here. Then we have the supply side and the demand side. So we are going to go through this problem as usual and then try to understand how the least cost method or the Matrix Maxima Method actually works. So I'm going to redraw this table in my escalate, and then inside my escalate you can see that I have the unit cost, that is the values we had in our table, in the cells in our table. I have the values at the top right corner where the blue lines are. So just as we had in the table, the example problem, I have 1, 2, 3, 4, 4, 3, 2, 0, 0, 2, 2, 1. Just as we had from the table, but this time I've placed it at the top right corner. And also we have the values at our supply side and the values at our demand side. So looking at this table, how did I go about using the least cost method or the Matrix Maxima Method to solve this transportation problem? Again, our main objective is to find the lowest or the shortest route to get the shortest cost to get to our destination. So how do we go about that? Looking at the entire table or the entire transportation table, we are going to look at all the cells and select the cell with the lowest unit cost. Now looking at the table, the cell with the lowest unit cost are 0 and 0. The first 0 being on the first column, which is D1, and the second 0 being on the fourth column, which is D4. So let's begin with the first column's 0. Now at the unit cost here, which is being 0, the demand side has the value 4 and the supply side has the value 10. Now, as we said, we are going to select the lowest unit cost in the entire transportation table. So we selected 0. Now we are going to allocate as much as possible the value to this cell. So allocate as much as possible to this cell. So how do we allocate as much as possible to this cell? We are going to look at the demand value, which is 4, and the supply value, which is 10, and pick the minimum value between them, which is 4, and put it at our cell location. So we're going to have the value 4 over here, just as I've done in green. So we allocate the value 4 to the 0 cell. Now on this column, just as we did in the previous video, the sum of all the values on the column should be equal to the value at the demand, and the sum of all the values on the row should be equal to the value at the supply. Now if you look over here at our demand side on the column, you realize that the value 4 is equal to the value at the demand. Now in the least cost method, once you have the values summing to the value at the demand or the supply, what you do is that you cancel out that entire row. So we are no longer working with that row. We see that we are done with that row. So we cancel the entire row and we no longer deal with it. So we are done with that. Now our focus is going to be on D2, D3, and D4. Now again, we are going to select the lowest unit cost in the entire transportation table and allocate as much as possible to that cell. Now, given D2, D3, and D4, what cell has the lowest unit cost? Again, it is the 0 we had before. So the 0 at the D4 column, this 0 has the lowest unit cost in the entire table, considering just D2, D3, and D4. And again, we are supposed to allocate as much as possible to this cell. How do we allocate as much as possible to this cell? Its demand side equals 6, and this supply side equals 8. Now we are going to allocate the minimum value between the 8 and the 6 to that cell, which gives us the value 6. Now, given the value 6, the value at the demand side for the D4 column is also 6. Since the sum of the value on that column is equal to the value at the demand, we can say that we are done with the D4 column. So what you do is that we can cancel it out or block it out of the table. So we've blocked two columns so far, D1 and D4. So they are no longer included in anything we do. They are out. So now we shift our focus to D2 and D3. Now again, we repeat the procedure. We are going to select the cell with the lowest unit cost. Now in D2 and D3, the values or the cells with the lowest unit cost is 2, 2, 2, and 2. We are going to start with the first 2, which is in the column D2. So how can we allocate a value to this D2 column? The supply side has a value 6, and the demand side also has the value 6. So between 6 and 6, we can allocate the value 6 to the 2 cell, which is at the D2 column. Now you can see that the supply side is satisfied. That is, the sum of the values on that row is equal to 6, which is at the supply side. And the sum of the values at the D2 column is also equal to 6 at the demand side. So what we are going to do is that we are going to cancel out the row and the column. So we are done with that row. We cancel out the entire row O1 and cancel out the entire column D2. Great. Now our focus is on D3, just these 2 cells, right? So if our focus is just on these 2 cells, and we know the total supply on O2 is 8, and we already have a value 6 here, then it's intuitive that the value at the cell 2 is going to be 2, since the total on that row is supposed to be 8, right? Now at the column D3, since the total on the D3 column is supposed to be 8, and we know that the value at the cell 2 is 2, then we can see that the value over here at the O3 row is also going to be 6. Why? This row O3 is supposed to be 10. We have 4 here already, so we can get a 6, which makes sense. And the D3 has a 2. To make an 8, we have a 6, which makes the whole table balanced. Great. So now that we are done with the D3 2, we can cancel it out, and we know that we are done with the entire table. So now to compute for the total cost for transporting the products from an origin to a particular destination, to compute for the total cost, we do 6 times 2, which is the value we had at D2, plus 2 times 2, plus 6 times 0, plus 4 times 0, plus 6 times 2, which gives us 28 as the total cost to transport the values or the products from their origin to their destination. So if you solve this same problem with the other method we did in the previous video, which is the northwest corner rule, you realize that the value we get over there is bigger than the 28 you are having here, which means that the least cost method is more effective than the northwest corner rule. So that's basically it for this video. You try to find or select the cell with the lowest unit cost in the entire transportation table and allocate as much as possible to that cell. And right you are done, you cancel out those cells, whether the row or the column, and you keep doing and keep repeating for the entire table. And once you are through with that, you should be able to compute for the total cost of the transportation table. Alright friends, so that's it for this video. Don't forget to like and subscribe. This is Dennis.